In this week, we're going to explore the Design and Technologies curriculum in more detail, and in particular, the year bands F to 8, so Foundation through to Year 8, and look at the actual curriculum in terms of its intent, and then some of the elaborations of the learning outcomes that are expected to be achieved by students at the end of the various band levels. In order to fully understand design technologies, we need to broaden your understanding of what actually technology involves and how pervasive technology is upon all human endeavours. Now we start by looking at the very earliest technologies, of fire, of the wheel, even of sticks and flint axes and things of that nature. All of these have been technologies. Then we have progressively more and more advanced technologies. Some of your grandparents, their ice box may have been a wooden box where they put a large block of ice and it kept the rest of the contents cold. Or they may have used a washing board instead of a more modern washing machine. So technology has changed dramatically in just a couple of generations. But all throughout human history, we've seen changes to technology. From the earliest printing presses and distribution of books, through to radio, through to mobile phones and digital technologies. Some applications of digital technology we never originally thought would be popular, such as putting a music device on our belt, or even in our toilets. And of course, sometimes technologies go awry, and we end up with solutions that may have been better thought through. There's a whole range of new technologies surrounding food, new innovative approaches to designing foods, and new ways of making them more nutritious. Then we've got other technologies. And next year we're all expecting to see hoverboards arrive, as predicted in the movies. But the reality is, skateboards have evolved in their design, and we actually do have hoverboards. Maybe not quite as exciting and innovative as the ones seen in Back to the Future, but they do work, and you can hover off the ground and skateboard across surfaces, including water. But then we've got a whole range of other technologies. Many people's lives have been saved by bionic technologies that have incorporated parts of machines into their own bodies through various aspects of artificial hips, through to artificial hearts, and a whole range of other technologies that we incorporate into our bodies. And this leads us into robotics. Many people have been fearful of robotics because of the potential for them to, if not replace human beings, certainly challenge human beings for our dominance. And we've got movies such as Terminator and so forth, and in the right bottom corner you see an actual artificial teacher that's actually being deployed in Japan, and it's used when teaching across multiple campuses. The teacher sits in one campus and controls the robot teachers in other campuses, and is having varying degrees of success. And the top right is a little Abo dog developed by Sony, but it's a robot dog, and I had one of these with my class about 6-7 years ago now, and it actually learnt entirely through trial and error, just like a small baby does. And it had to be trained how to walk, and then how to talk and recognize other people, and so forth. And we had students training that over the course of a year, and eventually it learnt how to walk and avoid stairs and follow certain students that it liked around. And it was a very good example of how artificial intelligence is, the moment we've got artificial intelligence achieving the level of intelligence of a cat. And we're now moving towards the level of intelligence of a dog, and progressively we'll have further and further advances in artificial intelligence until eventually it reaches at least the intelligence of human beings. And then it may start programming itself, and we may see some very interesting results. But of course there's a whole range of other technologies. One that we'll be looking at the workshop next week is 3D printing. And this is promising to revolutionize the way manufacturing is done. So instead of going into a shop and ordering from the small collection of items that are on display. You may go into a shop and they'll then print out the actual item that you wish to purchase. Already happens with books. You can go into some shops now and they'll print out a book for you. But 3D printing takes it to a much larger scale, where almost anything can be then replicated and made available for us. And the next step then is to go beyond the need for shops. And if we have 3D printers in our homes, we can then simply print off whatever we want to have. Now, at the moment, the majority of 3D printers just print out in plastic, but there are printers that print in metal. The United States military has got printers that will print out parts for tanks. So as they're racing around the battlefield and a tank gets damaged, they can print out a replacement part and install it and then keep on going. But we've also got printers that will print food. Some exciting new innovations in food science is happening, where we can print out various new culinary feasts with various ingredients extruded through the printers. And we've even got printers that will print out organic components, parts of the body, where we can print a new ear if someone has lost their ear and match it to the exact equivalent to the one that they'd lost, etc. So some very exciting things happening around technologies to do with innovative printing processes. But these are very different to what we call educational technology. Now, many of you in this course have sort of indicated in your introductions that you're really interested in learning about how to use technologies to improve your teaching and things of that nature. And that's what we call educational technology. And that's a subset of technology. It's not what we teach students. We don't teach students how to teach better using technology. But of course, as teachers, you're very interested in learning how to be more effective as a teacher. And while this course does not focus on educational technology in terms of teaching you it and preparing you for it, as I've mentioned in our introductory session, that has been integrated across all of your courses. You will have noticed that we do a lot of use of technology in this course, as you're watching at the moment. And you'll be creating small video clips and online documents and publishing things online and so forth. So you're going to learn a lot of the educational technologies that are available simply through doing the processes of the course. But unfortunately, this is not a course specifically about teaching you about educational technologies. The decision was made that that will occur in 4th year, and I'll see you again then, and we'll go through and see what you've learnt through your years of teacher education and identify what gaps there are and bring you up to speed before you finally graduate and go out and wow your potential employers and your colleagues when you get out into schools. But that's the current process. We used to do it in 1st year. We'd give you these courses and prepare you with all the skills, but the decision is that you'll develop those skills on your own generally and throughout your engagement with various courses. I know that imposes an additional challenge for many of you. I do sympathise, but there are support mechanisms in the library and so forth that will assist you, and I'll assist you to a certain extent in this course. But please understand that it's not a course in teaching you those fundamentals. Generally, you'll have to either develop those yourself or seek some assistance elsewhere to be able to incorporate educational technologies fully into your teaching. But let's look at some of the educational technologies. Most of my courses are around teaching this, so I'm very passionate around educational technologies, and I really wish I could do a lot more with these with you, but unfortunately this is sort of where I can sneak a little bit more in, but that's not what this course is about. So let's look at some educational technologies. We've got interactive whiteboards. Okay, you won't find a primary school now that doesn't have an interactive whiteboard. They've been very, very popular, quite controversial in many respects, but lots of primary schools now have got banks of computers, and many primary schools now have even gone to one-to-one, where every student has a device or computer all the time. The One Laptop Per Child program probably was the biggest driver of this. This was designed to be a $100 laptop, and they've made many hundreds of thousands of these and deployed them in third world countries. And I encourage you to have a look at that program and read a bit about that, because it's been a very successful program, and it really drove down the price of laptops, what became known as tablet computers, or the small laptops, notebook computers. Before the One Laptop Per Child program and the EXO computer came into being, laptops were generally about 1.5 to 2 times as expensive as a PC. Generally, you wouldn't get a laptop for less than $1,000, and most of them would be about $2,000. Nowadays, you can get a laptop for $200 or $300, and the price continues to drop. So we've got a lot to thank this program and the instigators of that. There's things such as virtual worlds. This is a virtual space called Second Life. I ran most of my university courses through this environment for a number of years and created the Griffith University Second Life. But virtual worlds, particularly this particular commercialization of virtual worlds, has gone off a little bit, and we're looking at probably more heading towards interactive computer games as being the space for education around virtualization. But again, in fourth year, we'll talk a lot more about virtual worlds and how you can incorporate those into your courses and your teaching. Then this is an example of some new technologies that I'm particularly interested in and doing my research around, where we use EEG headsets, and these actually measure your brain activity, and we study how you're actually learning based upon your actual thought processes. I've got sets of these kits, and we have students go through various learning tasks, and I measure their brain activity, and I can tell whether or not you're paying attention, whether or not the different areas of your brain that should be activated at certain times when you're doing certain learning activities are being activated, and then that provides guidance to teachers in terms of making interventions to assist the students. So that's an example of where educational technologies are sort of on the cutting edge. We don't have those fully deployed in schools yet, but that's certainly something I'm working on to try to achieve. So what is technology education? We've looked a bit about what technology is, we've looked a bit about what educational technology is, but technology education is always a bit confusing. Of course, most students equate it to digital technologies, or ICTs, okay, the latest iPhone or other device. But technology education sort of starts with arts and crafts, but we have to move beyond arts and craft. Okay? It'll involve a lot of the initial skills, but then we move into the actual design process. And we're going to talk a lot about the design process next week and the different strategies you can use to develop that in students. But really, it's all about completing design challenges, overcoming problems, problem solving, and engaging with different tools and techniques to achieve solutions. So that's very different to an arts and craft approach, whereby you might be creating an aesthetic, visually pleasing or engaging work of art. But students have a lot of fun in technology, or design and technology education, as I'll start calling it now, because they get to be very practical orientated, solving lots of problems, creating lots of artifacts, and engaging with various tools. Creating pop-up books is a great way. So it's not the artistic aspect we're really worried about here, although you could certainly integrate such tasks with arts and look at those things. We're worried about the actual mechanics and processes of actually creating the pop-up images and how to improve those and make them more effective and engaging. But it does involve a lot of planning and research and all of those aspects that we need to develop in students, and a lot of construction processes whereby they're actually building things and making things, learning how to use tools, and also processes such as cooking and following instructions and going through various processes to improve their final solutions, and sometimes the actual process they do to achieve that solution. And so let's look at one example. It's very popular and many of you would have done, and that is the egg drop challenge. Now the egg drop challenge can sometimes be done in science, where it's done as a scientific experiment looking at gravity and the effect of gravity and so forth. But from a design and technologies perspective, it's done to try to create a solution that solves a problem, and that is the problem of eggs breaking when dropped. And students go through a design process whereby they come up with different ideas of how to actually keep an egg safe. They might research aspects of eggs, they might research aspects of how other things are kept safe when they're falling, such as parachutes or putting wings on things, or gyrocopters or helicopter type solutions, or even things such as airbags and other aspects like that. So there's a whole range of potential solutions that can come out of their research into this. And again, getting a bit ahead of things, because we're going to be talking about the design process in a lot of detail next week. But it's all about coming up with lots and lots of ideas, then picking the best of those ideas and putting it into practice, and then evaluating how effective that idea was, and then ideally going back then and doing a bit more research, looking at some few new ideas and looking at the other ones that they may have discarded but now seem a lot better, and then trying it out again. So there's lots of competitions where students create egg drop challenge solutions, but let's look at one young boy and his attempts.
Oh, hey, what is Betty? There's so much to do with Saturday. There's an egg dropping contest. I make this contraption. I got way deep in there.
What are you making your contraption out of?
This is a football. There's three quarters. This is 3/4 of a football. And there's the lost. And here's the lost quarter.
What's the egg gonna do?
The egg's gonna be protected by this squishiness. And this fork makes the move for the egg. Look how deep that egg can go in. Well,
And then what do you do with the egg once it's in the contraption?
I'm gonna make another video of this when we at the end of the drop.
But where do you drop it?
Well, for this is a container. And this is the lid. So it has to go somewhere.
Okay, say goodbye.
Well, off to business. The video will be coming soon, I hope.
So this is an example of a design challenge, and a lot of design challenges are done outside of schools in various competitions and other activities such as scouting movements and Girl Guide movements and other activities that students can get involved in. But we'd like to see more and more of this activity-based learning or challenge-based learning occurring in schools. So let's see how Benny went.
What?
Hooray! How did you do it? Explain your contraption.
Well, the contraption worked. Look, they survived. They have done work. They have got these two eggs survive.
And how did the contraption work? Let's look at it. What was it?
I'm sorry you didn't get to the first one, but it cracked. I didn't want to tell you the move. I didn't want to tell you that.
Can you explain how this contraption?
This contraption works. A sponge is squishy. And this fluffs up. And this is this. It's a really good paper mache to our force field. Like these eggs to survive. Now I will win.
Okay, say goodbye.
I hope it happens again.
So it's a good example whereby Benny's first design and approach didn't work. Went through all the excitement of planning it and designing it and trying it out, and then finding out that it actually didn't work. And so then having to look at that and then come up with another design and hopefully improved upon what he's learnt from the previous trial. So that's the fundamentals of the design process, and we'll be talking more about that next week. But now let's look at the curriculum documents in a bit more detail to see how we structure these sorts of activities. Now, the design and technology subject, as we saw in brief last week, is focused around various concepts related to the technologies that we see in our everyday world. Now, apart from digital technologies, which is a special area that we've now got as a separate subject area, design and technology looks at all aspects of how technology is used in the world. And it relates to things to do with industrial design, home economics, agriculture, food technologies, and similar aspects that you might have come across in your own learning throughout your schooling. Now, it does look at economic, environmental and social impacts, although we do have a subject looking more specifically at the economic aspects of our curriculum. And of course you'll see aspects of environmental studies in science and also in geography. So there's a fair bit of overlap, and the technologies learning area is really looking at the fundamental engineering technical aspects of technology. But of course technology impacts upon all of our learning areas in various ways. So in particular, the subject aims to develop students' critical use of technologies and to be designers and producers of solutions. Now that's the important aspect. It's a very applied subject area where students are actually trying to solve problems and using various technological tools and processes to actually achieve those solutions. Okay, they're going to investigate, generate and critique innovative and ethically designed solutions for sustainable futures. So in all of the solutions that they come up with, they need to consider the ethics involved and whether or not they're sustainable, whether or not they have an impact upon our environment or impact upon society in various ways that make them unsustainable. And we also want to make them innovative, and with that goes creative. Now that's a big subject in itself, and we'll be discussing a bit of that next week in terms of trying to look at ways we can develop creativity and innovation in our students during their subject, during their studies. Using design and systems thinking to generate design ideas and communicate these to a range of audiences. Now that's probably the most difficult aspect of all areas of the technologies learning area. And in design and technology, getting students to think from a design perspective and from a systems perspective. And then in digital technologies, also incorporating computational thinking as a different perspective. It's these perspectives on the world that are the real fundamental aims and objectives of the technologies learning area. And while we do lots of activities and projects and design challenges, etc., as part of those studies, the outcome of the study is to get students to be able to see the world from a very different perspective. And unfortunately, most teachers don't have that perspective because it wasn't part of your own schooling. So it's going to be a big challenge for yourself to overcome your preconceptions of technology and of what technology education might involve to allow you to actually develop that in your students. But of course there are the applied aspects where students will produce design solutions suitable for a range of technologies contexts by selecting and manipulating a range of materials, systems, components, tools and equipment creatively, competently and safely, and managing these processes. So the context there, which we'll talk about in a bit, relate to things such as agriculture or food or engineering aspects, and we'll go through those. But within each of those contexts there'll be various materials that they'll need to become familiar with. Say in engineering there'll be different types of plastics or other materials that will have different properties that will make them more or less suitable for different solutions. In the food technologies area there'll be different foods that will have different nutritional aspects and how they relate to the design solutions. Then there'll be various systems whereby we explore not just the actual physical solutions but the entire system that surrounds it. So the process of actually making a product may have ways that can be improved or have impacts or design solutions that can be built in to assist that process. And again, we'll talk more about those things in our subsequent lectures. But there'll also be tools that they need to learn how to use and different items of equipment, being it a sewing machine or a cooktop or a buzzsaw. You might not think we give access to primary school students to electrical woodworking equipment and so forth, but there are quite a few schools that do have those setups where they've got full woodworking and metalworking labs where students do have access to those sort of devices. And of course then there's a whole range of safety aspects that go along with those. But just because you may not have used power tools and so forth in your own studies in primary school doesn't mean that necessarily the school you go into won't have access to those sorts of tools and be incorporating it into the students' learning. But not every school has those facilities, at least not yet. Then there's a process of evaluating processes and design solutions, so looking at the solutions either the students have made for themselves or solutions other people have made, and looking at how we can then transfer that knowledge from those solutions to develop new skills and apply them to new solutions. And then finally, understanding the role and responsibilities of people in design and technologies occupations. So what is involved in the agricultural industry as a farmer, for example, or the various trades that are involved in the industrial arts industries. Because there's a whole range of different career options and opportunities that students can be exposed to through their studies of design and technologies education. So, as we know, there is two strands. The first strand is knowledge and understanding, and the second strand is processes and production skills. But in the main, we interweave these to a large extent in all of our learning activities. But knowledge and understanding is the use, development and impact of technologies and design ideas across a range of technologies contexts. So really it's the theory. And then we have the production skills, or processes and production skills, which is the design processes that students go through to create solutions. So let's have a look a little bit more detail there. We've shown you that diagram before in that table last week. But the important thing is looking at these contexts, the technologies context. These are the four areas that you need to make sure you address during students' studies of design and technologies. The first is engineering principles and systems. The second is food and fiber production. The third is food specializations. And the fourth is materials and technologies specializations. So let's have a look at a couple of these. Okay, so the first is engineering principles and systems. And this is a focus on how we can create light, sound, heat, movement, control, or support in systems. Now I know that all sounds a bit strange, but really it's the engineering aspects. How we can actually, say, create some electronic circuit to produce a torch. And then how we could design that torch to create the most effective light for lighting a particular situation or solving a particular problem that relates to lighting. For sound, it might be making a musical instrument, and how we can create different musical instruments from various objects and design processes to create various sounds. And that's a great way of integrating with the arts. Heat could be focused on things to do with cooking and how we need to create a device to cook items. Creating a solar oven is a popular design challenge in that respect, whereby we create a solar oven in order to heat various food items to cook a meal. Then you've got movement. A popular one is creating a toy car or a model car and have that move, be it by elastic power, by elastic bands for example, or by wind power, or maybe by solar power. And you can then go on from that and create things that fly or things that go over water or even underwater. And so there's a whole lot of aspects around movement that we can incorporate into our design challenges and our solutions. Now control systems involve how we actually control various devices, and sometimes this can be through electronics, but sometimes also through mechanical means. It could be simple as the control mechanisms for a puppet, the different strings for a marionette and different bars and levers that we can use to control a puppet and how it moves. Or it could be a control system, computer-based control system to control a lighting system within a house or an alarm system. So there's a whole range of different aspects that we can incorporate into design challenges around control. And then you've got supports in systems, so how we can have systems that support the objectives of other tasks. So it might be a system say a traffic light system that supports the transport network by managing the processes involved in when cars can and can't move through a particular intersection. And students could study that and explore different ways that that occurs through their research, and then come up maybe with a better system for traffic lights. So there are a whole lot of the engineering principles and systems that are incorporated. There's lots and lots of example activities that we'll be exploring. I've provided you with a lot of those already in your design challenge tasks for your own assessment, but over the coming weeks we're going to be looking at lots of different examples of these. We've looked at one already today, the egg drop, a very common activity, but then you've got other common activities such as creating towers, creating bridges, very whole range of different aspects that can be incorporated, but they're just the basics. You might have your own particular areas of interests. You could create and it also depends upon the circumstances of the school and the access to resources you've got in your school. You might be a school in the hinterland, we've got access to jungles and things like that, and creating a flying fox would be a really easy activity to incorporate into student studies and solve various problems potentially with getting around areas of the school. But you might be a school here on the coast whereby creating a boat or cardboard boats where you go across a pool in boats students have made out of cardboard and duct tape. That's a popular activity. It does have some safety aspects, and I used to incorporate that in this course, but I decided to take it out because there was the potential for students to get into trouble making your own cardboard boats and going out into the broad water, etc. But they're things you need to think about when you do these sort of challenges. But then we've got our other areas, our other contexts. Food and fibre production. Now these are relatively new ones to design and technology, but they've been incorporated in, and we need to look at how they can be developed in terms of activities. So food and fibre production involves the growing of crops or growing of fibres, and could involve, say, raising of sheep for fibre production or for food production. And we do have schools that do have their own little farms and so forth. The Southport High School's got quite an extensive farm on their campus, and that's just down the road, where they've got animals and different crops that they harvest. So there's lots of different design challenges that can be incorporated into there. So for example, looking at different ways of growing plants that use very little water. And there's been lots of research around the world at solving that problem, and different technologies now, particularly the slow drip processes, or having the water directly applied to the roots of the systems to try to improve crop yields in areas where there's very low water. And students coming up with their own solutions of that can be an interesting and engaging design challenge. So again, we'll talk more about those different activities as we get to the detailed elaborations later on. Then you've got food specializations, and this is where we look at, in particular, nutrition, although that's also looked at in health and physical education, and looking at the various properties of food and food selection and preparation. Now, some of our popular TV shows around food presentation and cooking and so forth can be useful in exploring these, where students come up with new ways of cooking and new combinations of ingredients to come up with different cooked solutions. Now, there are some difficulties in that. Again, it's a new area for design and technology, and we're still working our way through how to incorporate that into the design process, particularly in measuring the nutritional quality of food and so forth. So it's an area that is complex at the moment, but it's one that is now part of design and technologies, and we need to look at how we can develop up activities for students to go about doing that allow them to engage with an understanding of food specializations. And certainly at the very high end, where you've got new designed foods, where the foods are made from different chemicals and so forth, that's being done in our very high-end restaurants. So that's an aspect that might be incorporated in. But then there's other basic aspects of food preparation and nutritional principles. But in order for it to be a substantial aspect of the design and technologies curriculum, we do need to go beyond just selecting some food for a lunch and things of that nature, because that's a fairly trivial design process. It's an important design process in terms of improvement of nutrition and improvement of student health, but that's where a focus in health and PE is very important. But our focus here is on the design process. And so looking at food preparation and so forth from a design process is the significant challenge. And that might be involving things such as better containers for different types of foods. So making a container that will keep a banana from being squished, but also keeping it without going overripe over several days could be an important design challenge. But there where we need to actually explore those processes. Then we have materials and technology specializations. Now this is looking at a whole range of existing materials that we use for various solutions. Now it might be a simple, or might be one example could be in terms of clothing. We've got a whole range of different materials that we can make clothing out of. From our raw fibers such as cotton or wool, through to the various plastics and other types of materials that have come from various oils and so forth that we've turned into plastics that can then be turned into various types of fiber or types of clothing. But then we've got other materials that might be usable. We've got carbon fibers that can be used, particularly in items such as bulletproof vests, but they could also be used in other types of fibers. There's various metallic fibers, there's a whole range of other different materials that can be used for making clothing. And so exploring the benefits and advantages of those different types of materials is an aspect of materials and technology specializations. But it could also be using, say, a common one is when making a some sort of accommodation or housing. Say if it's an activity where the students are looking at the problem of homelessness and coming up with their own design for a homeless shelter. Now some students might make it out of a tent-based material, out of clothing or cloth. Others might make it out of cardboard and having it from that design. Others might look at different metals or different woods and exploring the advantages and disadvantages of the different materials that go into creating that particular solution. But we've got other areas of communication and different materials we use for communication in medicine and recreation and transport. So there's a whole range of different aspects of design challenges that we can incorporate an exploration of materials and technology specializations. Okay, so the technology specializations is where we have particular technologies that are specialized for particular solutions, such as communications, but also in medicine and other areas where we've specialized, and we'll look at some of those examples as we go through the elaborations in a moment. But some of the specializations include architecture and the way we actually explore the design of buildings and in order to make them energy efficient or cooling. We're also safe from cyclones and things of that nature, or from floods. So there's a whole range of different things in architecture. Then there's in electronics, graphics, and in fashion. So they're the four contexts. Now you don't have to do all of them every year, but generally it's expected across the 2-year bands. So in years 5 and 6, or 3 and 4, or the 3-year time span you've got from foundation to year 2, you would have covered all 4. So that generally means you would cover 2 a semester, 2 a year, or 1 a semester. So it gives you a bit of a breakdown of how much time you should focus on each of them. Now that doesn't mean though you might decide to cover all 4 in a semester. But given the time constraints and so forth of how many hours you've got available for design and technology education, it's probably that you'll cover around about 1 of those specializations per semester. So 2 of them each year. Okay. So let's then look at the processes we go through in order to create these solutions. And we're going to be going through this in much greater detail next week. But just briefly, we have our design process, which involves an investigating phase, where students are exploring the needs of the people involved in the problem, the opportunities that might arise from the solutions related to that problem, and the information involved, such as the research and other examples of solutions that might already exist to that problem. Then they'll critique those and look at those and explore them in a lot more detail. So it's really a lot of value judgments, analysing various bits of information, questioning various concepts, and so forth. So that's really like the research component. Then from that, they generate lots of ideas. Now it's important to have the research or investigating component first, otherwise they're just generating ideas based upon very little knowledge and understanding of the situation. So after they've researched the problem, researched the situation, the needs of the different people involved, and all the rest that goes to do with investigation, they'll then generate a whole range of different possible solutions to that problem. So it's a lot more than just generating one solution. Okay? The idea is for them to go through a whole lot of creative processes to generate lots of different possible solutions, and then select the most effective solution they think will be achieved from one of those solutions. Again, we'll go through that in detail next week. Then they produce their solution, make their product or service or environment or system, and then put it into place to see how effective it is and evaluate their solution. And then they evaluate the solution based upon their initial investigation, and what we often incorporate into that is a defining step. Okay, hasn't been listed here, but part of the investigation and so forth is often defining what the problem is and then what a solution will be to that problem. And then you evaluate on how effective your solution has been at solving that particular problem. And throughout all of that, we have a collaborating and managing process whereby students learn to work together, manage their time and their resources and so forth as basically project management. Okay, so for our different year bands, we have a range of different outcomes that need to be achieved. So this is for knowledge and understanding, and there is the overarching aspect in technologies and society. So for example, in years 5 and 6, investigating how people in design and technologies occupations address competing considerations including sustainability in the design of products, services and environments. So that's looking at how these technologies that we're exploring in our schools are actually done in real life by people involved in those professions. But then we have there 4 different contexts: engineering principles and systems, investigate again, say in years 5 and 6, investigating how forces or electrical energy can control movement, sound and light in a designed product or system. Or in food and fibre production, investigating how and why food and fibres are produced in managed environments, such as a farm or so forth. And in food specialisation, investigating the role of food preparation in maintaining good health and the importance of food safety and hygiene. And then as part of materials and technology specialisation, investigating the characteristics and properties of a range of materials, systems, components and tools and equipment, and evaluate their impact of their use. So really choosing which is the best material or tool or system to use for various circumstances and learning how to use those effectively. So that's the knowledge and understanding. Now remember though, you don't have to do all of the specialisations every time you teach technologies education. Generally you'll focus on one each semester, although some tasks can incorporate multiple specialisations. Then you've got the processes and production skills, and this is our design cycle. And again, we'll be going through that in detail next week, so I won't spend too much time on that now. So let's look at a couple of the specific year levels. So from Foundation to Year 2, there's a range of different things that we want students to learn about at that level of understanding. And then there's the outcomes, what we expect them to be able to show that they can do at the end of Year 2. So for example, describe the purpose of familiar products. So what is a saw used for? What is a hammer used for? What is a sewing machine used for? Sort of the fundamental basics there, and at various services and environments. So why do we have a help option on some of our computer programs? Why do we have certain environments that, say, a farm, why does it have a whole range of different animals and plants grown on a farm rather than just a single animal or crop? Although there are monoculture farms available as well. So they could look at some of those aspects of why things are like they are. Identifying the features and using some of the technologies for each of the prescribed technologies contexts. So they have to have some understanding and some experience with the use of the technologies involved with the engineering or the food technologies and so forth, different contexts. And then with guidance, students create design solutions. That's the important aspect there. You're able to guide them through that development of their solutions for each of the different contexts. So they have to create a solution, so they have to look at a problem and then generate a solution for each of those 4 contexts over, in this case, the 3 years, but generally it's the 2 years that they do that. And then have some evaluation of their ideas. So how have their solutions actually met the problem that they were trying to solve? Now, each learning outcome has a specific STEM, which is the main aspect that needs to be achieved. And in this case, the learning outcome ACTDEK001 is to identify how people design and produce familiar products, services and environments, and consider sustainability to meet personal and local community needs. Now that's what needs to be achieved. Remember, this is a learning outcome for F-2. And then there are various elaborations or example approaches to how that can be achieved. Now, you don't have to achieve all of these examples. They're simply provided to help provide context to the outcome and provide you with some examples of ways that can be achieved. So for example, you could do a project around students looking at personal and family needs and comparing various recipes that they could produce to ensure that they're having a nutritious meal, and maybe then look at how they could do that when they went camping compared to how they would cook when they were at home. The different tools they would have for cooking, the different ingredients that they might have available, the ability to have refrigeration at home but not necessarily when they're out camping. These are all aspects that they could consider. You could even consider things such as not having bench tops or lighting when you're camping in the bush versus when you're camping in a kitchen. And so that might then have an impact upon what sort of foods they take along as ingredients, and then what sort of meals they prepare in those particular environments. So that would be an example of an activity that could be done, and that would address identifying how people design and produce familiar products, services and environments, and consider sustainability and meet personal and local community needs. So it doesn't have to address all of those aspects, but it certainly has to address the main thrust of that learning outcome. So let's look at some other examples. Let's jump through to another one still in years F-2, exploring the characteristics and products of materials and components that are used to produce design solutions. And here they might explore the various materials that are involved in making some clothing. So it might be to make a waterproof hat. And they could then look at the various materials that could be used for making a hat, and they could look at the waterproofing aspects of those materials. Then they also might look at the durability aspects, the attributes related to how easy it is to make the hat, like in terms of cutting the materials, or whether or not the materials degrade or even fade over time, or different colors are available. So there's a whole range of different things that can be considered in a simple activity such as making a hat, and looking at all the different materials that can be used and their characteristics and properties, and making decisions based upon the desired learning outcome or desired solution outcome, so what your solution needs to meet. And it might be a hat for students playing cricket, and that would be quite different for a hat designed for a teacher on playground duty. So you can look at the various aspects. You can look at some hats that are used for keeping the sun off versus hats that are designed for keeping the rain off, or hats that are designed for more protective aspects, such as when playing cricket. So there could be a whole range of different things that students could consider in their designs for hats. So, another one, let's look at visualize, generate, develop and communicate design ideas through describing, drawing and modeling. And here they might, again, it might be to do with their hat, and it would be going through a process of designing that hat, so it might be just designing it on paper, but they might then make, say, a cardboard model of the hat as a prototype and explore the functionality of that cardboard hat before they then start thinking about what other materials to make the hat out of. But they could try it out in cardboard or paper first and see whether or not it covers the head, whether or not it provides enough shading for the eyes and things of that nature, and even just the general size of the hats in terms of whether or not they'll fit on different students' heads or teachers' heads and things of that nature. So visualizing, generating and developing and communicating design ideas through describing, drawing and modeling can be an important aspect. So one thing you do need to think about when you look at these different learning outcomes is how they'll combine in a single project. Now you don't necessarily have to address every single learning outcome in every single project, but certainly over the 2 years or 3 years for years F to 2, all of the learning outcomes should be addressed. And you'll see that they go through, and we have quite a few of them, going down to number 9 in this case, sequence steps for design solutions and working collaboratively. So here, as part of their project, they might do a calendar that helps manage their times, or they might record what's happening with a video camera. Or an example here, recording the procedure for making a product. So if it's for making their hat, they might do a photo story. If they take photos of the different steps, or a video and narrate over the video, describing the process that they've used for making their hat. So they're all the different aspects you'll need to consider, and you'll be doing that in detail when you come to your portfolio of learning activities where you do up your design, your unit outlines. So years 3 and 4 moves on basically in progression. There's nothing substantially different. There's a few little slight differences in terms of sequences and so forth, but essentially you're going to be expanding upon the concept, skills and processes developed earlier, and that's a very important aspect of the curriculum. Okay? You don't always have to assume, or you shouldn't be assuming now, that students have no prior knowledge with the skills and ideas that they're going to be engaging with. You build upon what they already know. So years 3 and 4, you can read all that to yourself, of course, and at the end they should be able to meet similar outcomes but at a slightly more detailed level. So doing slightly more complex drawings and annotations and so forth. So again, looking at the various materials that they can be using, so forth. Let's pick an example we haven't talked about already. How about number 2? Investigate food and fibre production and food techniques used in modern and traditional societies. So here, there's some examples available, such as growing vegetables in a school garden, maybe making some houses for different types of animals. You might make some bird houses or possum houses, and see how they would suit, the different designs would suit different animals and plants, or sorry, different animals. Quite a lot of interesting projects being done by that, even some that have incorporated webcams and their digital technologies aspect, so you can then combine the two subjects. But here there's also a bit of a focus on looking at traditional societies, so looking at how plant and animal production happens today versus how it may have happened with our indigenous societies, and then looking at the nutritional aspects and so forth. So sometimes it will be difficult to get one project that addresses all of these areas, as I keep sort of reiterating. These elaborations do not need to be all achieved. It's just the STEM statement: investigate food and fibre production and food technologies used in modern and traditional societies. That's the aspect that has to be achieved, and it has to be achieved over a 2-year period. So you don't necessarily have to address, say, traditional society aspects every semester. But somewhere over those 2 years, there should be some aspect of looking at the food technologies used in the various contexts. Another one, critiquing needs or opportunities for designing and exploring and testing a variety of materials, components, tools and equipment and techniques needed to produce design solutions. So again, very similar to our example for the hats, but you need to be liaising with what the teachers have been doing in the earlier bands and indeed in the earlier years. Remember, you're doing this over 2-year blocks, or in the early years over 3-year blocks. So there has to be tight negotiation with the teachers in previous years, unless you're a teacher in a school that's taking the students all the way through, to ensure that all of the outcomes are achieved over those 2-year periods. So there's a fair bit of work that needs to be done in collaboration with your colleagues to ensure that that's achieved. But that should be happening anyhow in schools, certainly in our primary schools, but it can be a bit of a challenge for our years 7, 8, 9, 10, where they're not so used to ensuring that things occur collaboratively across multiple year levels. Certainly there's curriculum documents and so forth that are written, but there's a lot more flexibility now in the Australian curriculum in the way it's structured with these bands. That means there can be a bit of negotiation between the actual teachers teaching it as to who addresses what in the various year levels. So there's a whole range of elaborations for each of the year levels, and you can go through and have a look at those. Years 5 to 6, again continuing to expand upon the ideas and concepts in our progressive developmental curriculum. So I won't go through in great detail now and explore those. We will have a look at more and more examples as we go through the course and explore the different options and activities that people in the past have incorporated into design and technologies. There are literally thousands of lesson plans and unit ideas that are available for you to look at online, and a lot will rely upon your own particular interests and the interest in the context of the school that you're teaching. If you're, say, in an Indigenous school, then obviously you'll have a very strong focus on various aspects related to that. But if you're in a school that's got lots of labs and woodworking and metalworking rooms and so forth, then that may be a focus. But likewise, you might be in a school that has a lot of robotic kits and electronic kits, and that may be a focus. Or you might have access to digital printers and things of that nature. So you have a different perspective on what you try to achieve. Then you'll have different schools that are more engaged in external opportunities, such as competitions and science fairs and engineering fairs and things of that nature. And we'll talk a lot about that towards the end of this course, about how you can get your students involved in external opportunities for their learning, and that can be really enthusing, and whole curriculums that are then often built around particular foci. At my last school, as I was leaving, we had a new teacher that was very interested in space sciences, and he had arranged for students to, he was actually running the Australian competition for space science design, where students designed a settlement on the moon and competed all around the world, and the winners went and collected in NASA in the United States, and then they looked then in more detail about how to put those designs into practice. But that was a very engaging context, and a lot of activities were then built around that in science and engineering at that particular school. Other schools have got different foci. Some schools get very involved in the soapbox races or the solar challenges, where they try to make little cars run as many times as possible around a huge big track. And in fact, that was a big focus here in Southport. We had a number of schools that did the solar car challenge each year. But then there was also a big focus on the Formula One challenge, which was developed around the when the Formula One was held here on the Gold Coast. We had students designing Formula One model cars and testing those in computer software run wind tunnels, and then they were shaped in plastic, sort of like 3D printing, but it was plastic molding to create their models, and then they were tested again in wind tunnels. And then on the day of the big competition, all the schools and the students would gather to compete, and they'd test out their little dragster cars propelled by CO2 canisters at quite considerable speeds, and the most effective design of the shape of the car would win, often down to a few milliseconds between the different solutions. So it was a very competitive, engaging design, but it was all sponsored or supported by the Formula One car industry here in the Gold Coast at the time. and a very popular competition for many students. There has also been, at times, the boat building industry here in the Gold Coast sponsored a major competition held in the lake just over the road from the university in the Parklands showground area, the lake there. They would run a competition with different boat designs where students would design their boats and build them and then test them out on the little lake, and that was all a very engaging design technology competition for students here on the Gold Coast. So you may come into a school where there's already a culture of an existing processes involved in design and technology. It may be a school that's got a very strong home economics food production process where the students are involved in running their own restaurant. Quite a lot of our schools here in the Gold Coast, particularly the private schools, have got their own student-run restaurants that are developed, mostly focused on years 11 and 12, but many of them do have aspects that can be incorporated throughout the years leading up to that. And then there are various costume and clothing competitions that students can go into. There's the competitions held every year with the Gold Coast Show, where students can develop solutions and submit them in that. But I'm getting a bit ahead of myself. We'll be talking about those sort of activities towards the end of the course in a bit more detail. So for now, you need to go through and look at all the different band activities and think about how you would combine a number of these into one unit. Now you don't have to do it just yet. Got a few more weeks before you're ready to start writing your unit outlines and planning those. But at this stage, you should be getting an understanding of the sorts of activities and learning outcomes that are expected from design and technologies units of work, and be thinking about what sort of projects that you might be able to incorporate. Now, next week we're going to talk about how to actually design these projects and go through the design process and developmental processes of design challenges and so forth. So we'll wait to explore that in more detail then. But at this stage, you should now have a reasonable understanding of the learning outcomes required for design and technologies. Now remember, there'll be another set that we're going to look at in a few more weeks' time around digital technologies, but these are ones around design technologies. Now some of them are quite simple and easy to understand, like making a bridge out of balsa wood and seeing how it supports different weights, or creating clothing and testing the clothing and so forth. Others are a little bit more complex, such as around food technologies and so forth, where we'll explore some of those ideas and how you can put those into place. But in your tutorials, you'll be able to talk to your tutors and your peers about the different ideas that you've seen in the past in the schools that you've been involved in, or just ideas that you've thought of yourself, or ones that you come across in your research as you go through this course. So that's it for this week, and I trust that you'll explore what's in the learning outcomes in more detail, so that when we have our discussions, in our whole group discussion and in your tutor group discussions, you can unpack these in more detail. Bye for now.